This pencast will be on U substitution. It is used to find the antiderivative of integrals.
There are 3 steps to using the substitution method of integration to evaluate the integral. The first step is to substitute u equals g of x and du equals g prime of x to obtain the integral f of u du.
Step 2 is to integrate with respect to u. And step 3, replace u by g of x in the result. Here's an example of how u substitution can make a difference. Before we learned u substitution, we would have to take this equation and FOIL it to get the integral of 4x squared plus 4x plus 1 dx. Then, to find the antiderivative, we would use the power rule. So we get 4 over 3 x to the third plus 2x squared plus x plus c.
This doesn't seem that hard, but for other problems it can be more difficult. Let's see how u substitution can make this problem simpler. So you have the integral of 2x plus 1 squared dx. So we make u equal to 2x plus 1, and we take the derivative of that, so du is equal to 2 dx. So now we have to get the 2 dx into this problem. So we're going to multiply by 2 and multiply by 1/2 on the outside so that it's really keeping it the same, multiplying by 1. So now you have the integral of u squared du. Now use the power rule to integrate, and you get u to the third over 3, and that's still times 1/2 plus c. And that becomes, now you can plug in your u, so you have 1/2 2x plus 1 cubed over 3 plus c, which simplifies to 1/6 2x plus 1 cubed plus c. And if you were to multiply that out, you would get the same answer as the previous problem.
Here's an example with definite integrals. So you have the integral from 0 to 1 of 5x plus 4 to the 1/2. So first you want to figure out what u is. Dx. First you want to figure out what u is, and u will be equal to 5x plus 4. You take the derivative of u, which is 5 dx. So to get the du into the original equation, you multiply by 5, and then multiply 1/5 on the outside. So you get 1/5 integral of u to the 1/2 du. And then for the limits of this integral, they have to be with respect to u. So to find the limits, you just plug in the limits from the original, so 0 and 1, into the equation for u. So
0 plus 5 times 4 is equal to 4. Just kidding, that's equal to 20.
True, but the real equation was 5x plus 4, so 5 times 0 plus 4 is 4. And then 1 times 5 plus 4 is equal to 9. So then you solve it like a normal integral equation, and you pull out the 1/5, and then you get u to the 3/2 over 3/2 with the limits of u, so 4 to 9. This simplifies to 2/15 times, and you're going to do flopper minus flower, so 27 minus 8, and that gives you an answer of 38 over 15. Notice how with a definite integral, once we go to u, we stay with u and we don't go back to x.
Here is the general formula for a definite integral using u substitution. It's the integral with the limits a to b of f of g of x times g prime of x dx equals g of a, the integral from g to a to g to b, g of b, of f of u du. Now let's try some more problems. Okay, let's try the integral from 0 to natural log of 5 of e to the x over 3 plus e to the x dx. U is going to be equal to the 3 plus e to the x, or the denominator, and du is equal to e to the x because we know the derivative of 3 is 0 and e to the x is e to the x dx. So we're going to plug that into the equation. So we have 1 over u du, and the new limits are going to be, if we plug in 0, we get 3 plus 1, so we have 4. And if we plug in natural log of 5, we get 8 because e raised to the natural log of 5 is 5, and 3 plus 5 is 8. Now we know the integral of 1 over u is natural log of the absolute value of u, and we're going to do that from 4 to 8. So we have the natural log of 8 minus the natural log of 4, absolute values, equals the natural log of 2. And that's because this is really 2 to the third power minus 2 squared, which equals 3 natural log of 2 minus 2 natural log of 2, which simplifies to natural log of 2.
Now we're going to do a problem with trig. So we're going to do the integral of secant squared of 4x over tangent of 4x dx. U is going to be equal to the tangent of 4x, and du will be secant squared of 4x times 4 dx. And so to get du, we have to multiply the original by 4 and then the outside by 1/4. So we get 1/4 times the integral of du over u, and we anti-differentiate, so we get 1/4 times the natural log of u plus c, and then we plug in tangent of 4x for u, so the final answer will be 1/4 times the natural log of the absolute value of tangent of 4x plus c.
As you can see, u substitution can make all kinds of problems a lot simpler, including trig, natural log, and exponents.